Good afternoon, everyone, and welcome to our video on finding confidence intervals with z-score. Confidence intervals are used to find a range of numbers where the population mean may exist. In a perfect world, you would like to calculate the population mean wherever you can, because remember, population means everything. But sometimes that's not possible. Like, let's say you wanted to find the age of the average American. There's over 300 million people that live in the United States, and people are dying, being born, immigrating, and emigrating every second. So I can't be certain to get a population mean of the average age of an American. So what we can do is take a sample, nice random sample, find the mean of that and the standard deviation of that, and create a confidence interval. So the first step of this is to find the z-scores. And if you look on your z-chart, specifically the bottom left-hand corner, you will see a box that says critical values. Typically, when they ask confidence interval questions, they do the same three questions over and over: 90%, 95%, or 99%. Once you have that, the next step is to find error using z-score times standard divide square root of sample size. And by the way, standard and sample size must be given. And then step 3 is to do mean minus error and mean plus error. That's how you get your two numbers. And mean has to be given. But as always, it's always easier to show than it is to explain. So let's do some examples together. Okay, we have a sample of 20 math instructors, had a mean salary of $50,000 and a population standard deviation of 6,700. Find the 90% confidence interval. So the first step we have to do is find the z-score for this. And if you look on your chart, the z-score for 90% is 1.645. All right, great. Step 2 is to use our formula for finding error. So what we're going to do is we're going to do z, which is 1.645, times the standard, which is 6,700, and then divide that by the square root of 20. Let me fill in the fraction line and the square root, something like that. And if we put that in the calculator, our standard deviation is going to equal to 2,464. Okay, very good. Now the last step is to do mean minus and mean plus. That way we'll get our two answers. So let's take a look. So first we'll do 50,000 minus 2,464. And that's equal to 47,536. Next, we will do 50,000 plus 2,464, and that's equal to 52,464. So if you had to kind of summarize this, you can say that we are 90% confident that the population mean salary of math instructors is between $47,536 and $52,464. We don't necessarily know the population mean for salary, and we don't need to know it. We just need a confidence interval to show us where it might be. All right. Example 2. Sample of 17 students have a mean grade of 79 and a population standard deviation of 7. Find the 95% confidence interval. All right, well, let's do this again. The very first step is to look on our z-chart and look for the z-score for 90%. And that should be 1.96. Great. All right, next step is to find the error. So the error will be the z-score, which is 1.96, times the standard deviation, 7, divided by the square root of 17. And let me fill in some things. Fraction sign, square root sign. And that is going to equal to 3.3. All right, now finally, we're going to do mean minus the error and mean plus the error. So we're going to do 79 minus 3.3, which is equal to 75.7. Does that. And then we're going to do 79 plus 3.3, which is equal to, and I forgot this 0.7. Yeah, let me get that in there. And then 79 plus 3.3 is 82.3. So that means our confidence interval is 75.7 to 82.3. What that means is we are 95% confident that the mean grade of all students is somewhere between 75.7 and 82.3. Okay, example 3. 13 red lights have a wait time of 170 seconds with a population standard deviation of 23 seconds. Find the 99% confidence. Well, first step is to find the z-score for 99% confidence. So for that, z is equal to 2.575. All right, next we're going to find the error. So we're going to do 2.575 times the standard, which is 23, and then divide by the square root of 13. Let me fill in some stuff. Here's our division sign, here's our square root sign. And if we put that in the calculator, we are going to get 16.4. Okay. Finally, we can do mean minus the error and mean plus the error. So we're going to do 170 subtract 16.4, which is equal to 153.6. And then 170 plus 16.4, which is equal to 186.4. So our confidence interval is 153.6 to 186.4. All right, very good. Next is example 4. Find the 95% confidence interval. So once again, we need a z-score for 95%. And for that, I already know z is going to equal to 1.96. Now we're going to use our formula. So it's going to be 1.96 times the standard, which is 6, divided by the square root of 26. So we got the division, we got the square root, all right. And if we put that in the calculator, the error is 2.3. All right, terrific. Now it's time to do mean minus error and mean plus error. So we're going to do 28 minus 2.3, which is equal to 25.7, and 28 plus 2.3, which is 30.3. So our confidence interval is 25.7 to 30.3. Just like that. Okay, so just some basic information. Bigger confidence is always wider. So 99% is wider than 95, and 95 is wider than 90. And if you have to interpret, the keywords are confident, population, in between. So if our 99% confidence interval was 2.86 to 324, we would say we are 99% confident that the population mean is between 2.86 and 3.24. So notice those 3 keywords. All right, now you can answer questions 1 through 6 on homework 6. If you have any questions, please let me know. Otherwise, have a great day.